Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to do some example problems about Hess Law. Our objective for today is to practice about Hess Law problems. Earlier today, I gave an exam to my students, and that was a sample of one student. And I feel that my students need to do more practicing about the Hess Law problems. So let's start with the first problem. Calculate the heat of reaction for PbCl2 plus Cl2 yields to PbCl4 and delta H is unknown. We call this reaction the one that we need to find delta H for the reaction. We call it the desired reaction. And by combining, we have reaction A and we have reaction B. In reaction A, Pb plus Cl2 yields to PbCl2 and delta H is given. Reaction B, Pb plus 2Cl2 yields to PbCl4 and also your delta H is given. Now, what we need to do is to check always the reactants, what do we have, and the products also, what do we need to have. In reaction A, as you can see, we have PbCl2, 1 mole in the products, but we needed 1 mole in the reactants. So I'm going to flip reaction A. Flipping reaction A, it means that the products will become the reactants and the reactants will become the products. Whenever we flip the chemical reaction, we need to multiply everything by negative 1, including the delta H, as you can see. So reaction A, I'm going to give it a star because we're going to rewrite it or we're going to adjust it. So it's going to be PbCl2 yields to Pb plus Cl2. And delta H for our reaction now, it equals to, because we multiplied by negative 1, it's going to equal positive 359.4 kilojoules. Also, we have PbCl4 as a product, and from reaction B, you will find that PbCl4 is a product also. We need 1 mole, and we have it 1 mole. So basically, in reaction B, we're not going to do anything. So nothing to be done in reaction, or no change for reaction B. So B is going to be as it is, Pb plus 2Cl2 yields to PbCl4, and delta H for the reaction is going to be the same, negative 329.3 kilojoules. Now, let's add reaction A star and B to check if we get the desired reaction or not. If we get it, that means our solution is correct. In the reactants, we have PbCl2, and we don't have any PbCl2, so I'm going to write it as it is, PbCl2 in the reactant. In the products, we have Pb, and also in the reactant, we have Pb. 1 mole and 1 mole, so they're going to cancel each other. Also for Cl2, we have 1 mole Cl2 in the products, and we have 2 Cl2 in the reactant. So Cl2 here will be cancelled, and 1 mole of Cl2 will be cancelled, leaving it as 1 mole in the reactant, so plus Cl2. Yields to, we don't have any other PbCl4 except for this one in the product, so I'm going to write it as it is, PbCl4. And if you check now, we will have the desired reaction. So our work is correct. Now delta H for this reaction, because we combined these two reactions, I'm going to combine or add delta H for reaction A star with delta H for reaction B. So it's going to equal to 359.4 minus 329.3, it will equal to 30.1 kilojoule, and it's positive. All right, now this is how we solve the problem when we have a free response question problem. But sometimes, or usually, those easy problems, they come as multiple choice questions. So what we're going to do, instead of wasting, it will take longer time like this. All we need to do is to check this one 1 mole, this one 1 mole, reactant. We have it here product, so I'm going to flip it, multiply it by -1, so it equals to 359.4 kilojoules. The second one, product, we have it in the product, 1 mole, 1 mole, so nothing. So I'm going to multiply it by 1. It means we didn't do anything to it. So it equals to -329.3. Now we are going to add delta H to delta H, or delta H with delta H, and we will have the delta H final. If we have long time for this exam, we can double check by writing or adjusting or rewriting the equations. Problem number 2, I want you guys to pause the video and try to solve it on your own. All right, from the following heats of reaction, we have reaction A, reaction B. We need to calculate the heat for the desired reaction. All right. We have S and O2 in the reactants. We have SO2 in the products. Basically, when we have two reactions and they are sharing the same species, for example, O2 and O2, we don't care about O2 where it is. So we don't care now about O2 whether it's in the reactant or the product. We care about the other things because they need to cancel each other. We have SO2 or we need SO2 1 mole in the product, but from reaction A, we're going to have it 2 SO2 in the reactant. So basically, I'm going to multiply it first of all by half, and also I need to flip it. I need this one in the product, so it's going to be -half. And delta H will equal to positive 98 kilojoules. In reaction B, we need now S 1 mole in the reactant, but we have it 2 moles in the reactant, not in the product. So I'm going to multiply it also by half without the negative sign because we keep it as it is, the reactant and the products, we don't flip them. So it's going to equal to 300 negative 395 kilojoule negative. Now I'm going to add these two reactions together. It's going to equal to -297. Now this is if the question was a multiple choice question. Now if we need to solve it, all right, the first reaction, we're going to multiply it by -half. It means we need to flip it and we divide everything by 2. So A star, it will equal to SO3 1 mole because we divided by 2 or we multiplied by half, yields to SO2 only 1 mole plus 1/2 or half O2. And delta H for this reaction, it equals to positive 98 kilojoules. In reaction B star, we need the S in the reactant and we need only 1 mole of it here, 1 mole. So I'm going to multiply it by half. It's going to equal to S plus 3/2 O2 yields to SO3, and delta H equals to -395 kilojoules. Now, we're going to add these two reactions to check if we have or if we get the desired reaction or not. SO3, cancel SO3, half O2 and 1.5 O2. So the half O2 will be cancelled and this one will be cancelled, leaving 1 mole only of O2. So I'm going to write it. S plus O2 yields to SO2. And that is the desired reaction that we need. So our work was correct, and delta H, by adding these two heats of reactions, is going to equal to -297. 97 kilojoule. All right. Problem number 3. The standard heats of formation of HCl and HBr are given. Using those information, calculate delta H for the following reaction. Don't forget that delta H from the heat of formation, so delta H Rxn standard, it equals to the sum of delta H of formation of the products, and of course it's standard, that's why we put the circle here. If you have any problem with those guys, I would like you to go back and check the previous videos about Hess law and the thermochemistry. So the sum of delta HF for the products minus the sum of delta HF standard for the reactants. Now, don't forget that for the diatomic molecules, or when they are in the stable states or the most stable states, it's going to equal to 0. So for this one, delta H formation standard, it equals to 0. And for the Cl2 also, delta H formation standard also equals to 0. Now, the delta Rxn, delta HRxn for this reaction, it will equal to the products, which is 2HCl. We have 2 moles, so I need to multiply by 2 for the HCl, which is negative 92, minus the delta HF for the HBr. Also, we have 2 moles, so I'm going to multiply it by 2, and it's going to be negative 36.4, and delta H for this reaction will equal to negative 111.2 kilojoule. All right. Problem number 4. Given the following equations, you have equation A, equation B. Using these two equations, determine the heat of formation, delta HF, for the nitrogen monoxide. Now, you are not giving a desired reaction. You are giving, they need the heat of formation. And if you remember from previous video, the heat of formation, for example, for any compound, it should be in its standard state. It should be from the elements, and it should be for 1 mole of the compound, and it should be from elements at their standard states. 4 things. Review the video. So, NO, we need the formation reaction. So NO is a gas, and we need 1 mole. And the elements that make the NO is oxygen, O2, plus the nitrogen, N2. All of them are gases. So 1 mole of NO, 1 mole, oxygen element, nitrogen element, both of them are gases. To balance this equation, we can multiply this one by 2. But if we multiply it by 2, it will become 2 moles, not 1 mole. And the heat of formation, we need 1 mole of the compound at its standard state. So I'm going to multiply this one by half and multiply this one by half. Now, to solve this problem, we have equation A and we have equation B. As I told you, we have NH3 and NH3, so we don't care about it. We care about the NO, and we care about the N2 in this case, because also O2 and O2, we don't care about it. We have them in both reactions. H2O and H2O on both reactions, we don't care about them. So basically what we care about is NO, because it's the only one species in one reactant, and N2 is the only one species in another reactant. So we need N2 in the reactant, and we need half of it. But in reaction B star, we have it in the product and we have it 2 moles. So first of all, I need to flip it. That means I'm going to multiply it by -1. And also I need half of it. So I'm going to multiply it by 1/4 because I have 2. I need half. So I'm going to multiply it by -1/4. B star, after we flip it and multiply it by 1/4, 6/4 H2O plus half N2 yields to 1 NH3 plus 3/4 O2. In reaction A, we need the N2, we need the NO. We need it in the product and we need 1 mole. And here we have 1 mole, 4 moles, but in the product also. So I'm going only to multiply it by 1/4 without flipping. So it's going to be NH3 plus 5/2 O2 yields to only 1 NO now plus 6/4 H2O. Now delta H for reaction B star, it will equals to 382.5 kilojoule, and it's positive. Delta H for reaction A star, it equals to -292.5 kilojoules. Let's add reaction A star and B star to check whether we have the desired reaction or not. 6/4 H2, 6/4 H2, half N2, we have it. NH3 and NH3 cancel each other. O2, 5/2 minus 3/4, it will equal to half O2 yields to NO. So it's exactly the desired reaction. And delta H, we can add these two delta H's to have -292.5 plus 382.5 will equal to 90 kilojoule positive. All right. So the trick question about this is not only Hess law, but also they included the heat of formation. We need to remember or recall that the heat of formation, it means for the formation reaction, and the formation reaction we need 1 mole of the product at its standard state and from elements at their standard states. All right, the last question, boys and girls, I'm going to leave it on you. You need to practice about this problem solving, and we're going to solve it next video in the thermodynamics. Given the following data, A, B, C, you have 3 reactions now. Use Hess law to calculate delta H Rxn for the following reaction, and you are given desired reaction. Here is delta H, unknown. Try to solve it, and we're going to check the answers next video. I hope you guys learned something new today. Have a nice day. Bye-bye.